Hello everyone. So far in the confined masonry construction, we have looked about construction sequence, load transfer, material specifications, building configuration and ductile detailing of confined masonry walls. Today we will look further into ductile detailing of confining elements, that is tie beams and tie columns, as well as the joint, that is the tie column tie beam joint. So, let us first look into the geometry and locations of these confining elements. When it comes to tie columns and tie beams, they shall be made of reinforced concrete. We have looked at the minimum grade of concrete that is allowed is M15 and the minimum grade of steel that is allowed is Fe415. The minimum dimension of these RC tie columns and tie beams shall be given by depth into width, which shall be 150 mm by wall thickness. So, one of the dimensions of the reinforced concrete tie column as well as tie beam shall be equal to the wall thickness. The other dimension, that is the depth, can be anything more than 150 millimeters. Now, where do you place or construct your confining element? In case of tie columns, you construct tie columns at the wall intersections or at intermediate locations in longer walls with a spacing up to 1.5 times the clear height or 4 meter, whichever is lower, which means that if your clear height of the wall is, let us say, 3 meter, then you can go for a spacing of 4 meter, because this becomes 4.5 and this becomes 4 meter. So, whichever is lower, you have to place tie columns at a spacing of 4 meter or lower. Then the free ends of wall panels that provide lateral load resistance to the building, they should also have tie columns at the free ends. In case of beams, these shall be provided at top of each wall, and again the spacing shall not exceed 4 meters. Now, let us also understand about the horizontal lintel bands particularly. If your unsupported height of wall is more than 2.5 meter, we need to provide continuous horizontal lintel band over the openings. If your unsupported height of wall is up to 2.5 meter, then we can provide horizontal lintel band over the openings separately. What does it mean? Usually you will find that the door height is 2 to 2.2 meters only. So, in most of the cases, if you provide a lintel band over the openings, that should be sufficient. But if your opening is going up to, let us say, 2.5 meter, then you must provide continuous horizontal lintel band. The lintel band should be continuous in that case. But here, apart from these guidelines, I should also recommend that you should be providing continuous horizontal lintel bands for good seismic performance, even if the unsupported height of wall is less than 2.5 meters. That will help you achieve desired seismic performance. Now, once we have understood about geometry and locations for these confining elements, we shall look into the reinforcement detailing of these confining elements. So, when it comes to reinforcement detailing, we shall be seeing two things, that is the longitudinal steel and the transverse steel. Here we can see a schematic diagram of a wall intersection where you have the tie column in the vertical direction and you have tie beams in the horizontal direction. At this point, you shall be able to tell that in the tie beam you have this longitudinal reinforcement and you have also transverse reinforcement. In case of the tie column, the longitudinal reinforcement is shown over here, the transverse reinforcement is not shown for clarity of the picture. So, the longitudinal reinforcement in case of tie beams or tie columns shall comprise of minimum 4 numbers of bars. So, typically you will find that these tie beams or tie columns have dimensions of 150 mm by 150 mm or 150 mm by the wall thickness and so on. So, in such cases what you will observe that providing 4 number of bars should be sufficient in most of the cases. Now, this is very lightly reinforced compared to reinforced concrete frame buildings. The minimum diameter of bars that you shall use as longitudinal steel in tie beam as well as tie column shall be 10 mm dia bars, and also you need to provide minimum concrete cover of 20 millimeters. Now, you may realize that the minimum concrete cover that is allowed in case of confined masonry construction is lower than that allowed in reinforced concrete construction. There are a number of factors behind that. First of all, when you are constructing a confined masonry building, then your load resisting system comprises of the wall as well as these confining elements. But when you are constructing a reinforced concrete frame building, then your frame is the load bearing system, and therefore you cannot expect a deterioration in strength or a poor durability in case of reinforced concrete frame. But in case of confined masonry construction, since the load carrying system comprises of walls as well as these confining elements, you can afford to have some deterioration with time or some loss in durability. Another point in this favor is that the dimension of tie beams and tie columns is much lower as compared to the dimension of RC beams and RC columns in an RC frame building, and therefore the clear cover also has to be lower in this case of confined masonry construction. Now, apart from these longitudinal steel, you need to anchor these longitudinal steel whenever you have a corner joint. For example, you have a corner joint over here, you have walls which are orthogonal meeting at a certain point. Now, at such locations, all the longitudinal steel in these tie beams shall be anchored into the beam which is perpendicular to that beam, and this will be done through 90-degree hooked anchorage as shown in detail in this very diagram. You can see there is a 90-degree hooked anchorage shown over here, and the anchorage length shall be either 20 times the bar diameter or 500 mm, whichever is larger. And at the roof level, for the columns, the longitudinal bar will be bent into the longitudinal reinforcement in the tie beam. So, it shall be lapped with the longitudinal reinforcement in the tie beam. So, the longitudinal steel bars in the column will be turned by 90-degree at the roof level, and it will be lapped with the longitudinal steel in the tie beam. Now, many times you will also need to splice these longitudinal steel bars because the steel bars are available in limited length. In that case, the minimum lap splice length shall be taken as 40 times the bar diameter. This is also lower than that considered in case of RC frame building. How? There the splice length is a function of bar diameter as well, but there it is mostly in the range of 48 to 50 times of bar diameter, commonly taken as that. Here it is 40 times the bar diameter, and the splicing has to be done in the middle third of the span, which means you cannot splice in the 1/3 of the span from either end. In the middle 1/3 you can provide the splicing, and that splicing has to be staggered. So, maximum 2 bars can be spliced at one location. We have mentioned that minimum number of bars shall be 4. So, out of 4 bars you can splice only 2 bars at a given location. Now, you will ask that how will you provide the splicing if you can provide a splicing in only 1/3 of the span, and that too only 2 bars can be spliced at one location, fine. The distance between the tie columns and tie beams is much lesser, which is 4 meters in this case. So, out of 4 meters, the middle 1.33 meter you can provide a splicing of 2 bars, and in the next span you can provide splicing for the remaining 2 bars. So, that way you can proceed. Now, we shall discuss about the ductile detailing of these tie beams and tie columns pertaining to transverse steel. What is transverse steel? Transverse steel, which are commonly called as stirrups, are supposed to carry shear forces. What shall be the minimum diameter of these bars? They shall be minimum diameter of 6 millimeters, and we shall also provide 135-degree hooks with a staggered arrangement as shown over here. You can notice that in the tie column this has been put as staggered arrangement as shown over here. The hooks are staggered when it comes to consecutive stirrups or hooks. Now, if you are constructing a confined masonry building in seismic zone 4 or 5, then you need to reduce the tie spacing at the ends of the tie column. So, as you can see in this very figure, as we move closer to the column ends, we have reduced the spacing of the transverse reinforcement. Why do we reduce it? It is very similar to the case of a special confining reinforcement, which we have studied in case of reinforced concrete buildings, probably in weeks 5 and 6. Now, the zone of reduced tie spacing shall have a length which is more than twice the larger column dimension and 1/6 of tie column clear floor height. So, that has to be minimum length of the zone where you need to provide reduced tie spacing. Okay. Once you have understood the specifications related to longitudinal steel and transverse steel in case of tie beams and tie columns, now let us also understand the reinforcement detailing related to their joints, that is the tie column to tie beam joints. In any joint, you shall ensure the continuity of longitudinal tie beam reinforcement through the joint. So, the longitudinal steel of the tie beam shall be kept continuous, and the longitudinal steel of tie column shall also be kept continuous. However, in case of columns, you need to also make the stirrups continuous. Now, the first tie shall be placed at both ends of the tie column as close to the joint as possible, which means we are talking about these first ties. So, they shall be very close to the beam column joint, as you can see. Now, what happens if your tie beam depth is very large? If your tie beam depth is exceeding 300 millimeters, then in such cases we need to provide a U-shaped stirrup at the mid height level of the tie beam. In the plan it shows like this, in the elevation it appears like this. So, this U-shaped stirrup helps us provide enough torsional rigidity to the beam which has a lower torsional rigidity. Why? Because the width is still equal to the thickness of the wall, but the depth is 300 millimeters. So, that is why we provide this U-shaped stirrup at the mid height level of the tie beam as shown over here. Now, once we have understood the ductile detailing of tie beams, tie columns and tie column to tie beam joints, now let us quickly look into some good construction practices related to confined masonry construction. So, first of all, connect all the intersecting walls to assure stability and good performance. Now, this connection has to be made through either toothing the surface or providing dowel bars. Now, when you have constructed the masonry wall and provided a toothing surface or dowels, then you shall clean, roughen and wet the surface before proceeding with further construction. What is the further construction? The further construction would be to cast the tie columns and tie beams. So, why do we need to clean, roughen and wet the surface beforehand? Because if we do not wet the surface, then the masonry unit shall try to absorb water from the concrete which is poured or cast in tie beams and tie columns. So, in order to avoid that and provide a good bond between the two, we shall clean, roughen and wet the surface before proceeding with further construction. Now, over the time, researchers have found that Flemish bond and English bond works well and gives good seismic performance for confined masonry construction. So, in the brick work for confined masonry construction, you shall be adopting either Flemish bond or English bond. Then we shall be exercising necessary caution to assure wall stability during construction and clean the surfaces of toothed masonry wall before casting tie column. This cleaning also helps us improve the durability of the confining element, that is the tie column. So, summarizing, in today's class we have discussed about ductile detailing of tie beams, tie columns and tie joints, and also we have looked into some good construction practices related to confined masonry buildings. In the next class, we will look into the design procedure for confined masonry buildings as per IS 17848 2022. Thank you.